Okay, so this second video now is going to look at a few of those key terms that we've looked at in the last few days, and try to provide a few more examples of Newton's first law. So the first thing is a balanced force, and you need to remember that with balanced forces, basically it's two forces going in opposite direction that are equal in size. So here, if we look at the force pushing up, there's a force of 10 newtons pushing up, but there's also a force of 10 newtons pulling down. And if we take this to find net force, we basically subtract one force from the other. If we take 10 minus 10, we get a net force of 0, which means that they are balanced. Same thing with going left and going right. 12 minus 12 gives us 0, which means that the forces are equal, but in opposite directions. Balanced forces affect the movement of an object by keeping them doing what they were doing. So this is that idea of inertia. Inertia is where an object is going to resist change. It's going to keep doing what it's doing. Okay? So if an object is moving and we have balanced forces, it's going to keep moving in the same speed in the same direction. So like we saw with the box before, it's going to keep going at the same speed, and it's just going to keep going forever and ever and ever until an unbalanced force acts on it. Unbalanced forces can cause a change in the motion. So they can cause a change in the speed that the object is going, so they can accelerate an object. They can cause a change of direction. They can stop an object from moving, or they can start an object from moving. Okay, lastly, or well, not lastly, but next we have net force. And net force is just the sum or the total of all of the forces. What we do is we basically look at all of the forces, and we have to remember we have our number line. So if things are going left, they're going to be negative, and if things are going right, they're going to be positive. And we basically take the difference of the forces. So we take 10 minus 14, which gives us -4 or 4 newtons. You can also do it the other way around. 14 minus 10, you're still going to get 4 newtons as the unbalanced force. Okay? To make the forces balanced, you would have to increase the 10 newtons until it becomes 14 so that they are equal, or you have to decrease 14 to become 10. Okay, so net force, basically, you're just subtracting opposite forces to find out what the difference between their values is. Okay? Friction is a force that exists on Earth with everything. So you can find friction in the air, you can find friction in the water. If you rub your hands together, you feel the heat. Okay, that is because of friction. So basically, friction is when two objects rub or slide against each other, and there's a resistance to the movement again, and it comes through as heat. Okay, so if you rub your hands together really quickly, you'll feel them, they'll feel nice and warm. That is because of friction. Okay, friction, because it is a force, is measured in newtons. Just another word, applied force. This is when you actually put a force onto an object from something else. Okay, so for example, if you push a box, if you lift your backpack up, you push your chair in, those are all applied forces. And last little bit, this is Newton. This is a picture of him, of who kind of came up with these rules or laws of motion. He's also credited with kind of discovering gravity as well. Okay. And then the last concept was the concept of inertia. Inertia is that idea of trying to stay the same, so resisting change. Objects with more mass will have more inertia. So, for example, if you try to push your parents, if you're smaller than your parents, you probably have to push harder to get them to move than if you were pushing somebody the same size as you or smaller. Okay? So if objects with more mass are much harder to move. For example, you can push a pen on the table with your pinky finger very easily, but it would be very difficult to move a car or a truck that you ride in. It would be difficult to move them with your pinky. Okay, and that's because the car has a mass of about 1,500 kilos, so 1,500 kilograms.